Why choose this as our goal? And they may well ask, why climb the highest mountain? Why 35 years ago fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Hi, I'm Eric Ray, Curator of Collections and Exhibits at the Museum of the Coastal Bend here in Victoria, Texas. I take care of all of the collections here at our museum, and I make sure that we have exhibits to share those collections and share the stories of our area's history and heritage with the public. This area has had a long history in space exploration. Texas is home to one of the largest scientific balloon facilities in the world. This is an area of spaceflight that we didn't really know about. We found out a lot of people didn't either. These are balloons, a lot of people call them weather balloons, that'll take small scientific experiments up to about 110,000 feet and experience what the world is like essentially in space, but at a much lower cost and a much lower barrier to entry, much easier to get to than actual space. So we realized that this is a thing we could do at the museum to help get people interested in science and help share this part of Texas's heritage with them. This year we've done 2 balloon launches, 2 different groups of kids. They've designed the experiments and we sent them up to near space. This is not a thing that any of them had done before. This is not a thing that most people get a chance to do. So we had to tell them what to expect and get them interested in the idea, which wasn't hard to do, and tell them exactly how to engineer and design their experiments to go to the edge of space.
So it's cheese and a crayon, both meant? That's the crayon's in the other one.
Yeah.
Okay, and what do you think will happen to the crayon?
Oh, no. Freeze and then it'll melt.
Yeah, freeze and it'll melt. So, do you think it'll look the same as this when we get it back? No?
It'll be like the cheese.
Be like, okay, it'll look like a cheese, alright.
But it'll smell.
Okay, it won't melt. It won't melt?
It'll melt, but it won't smell.
Won't smell, okay. Alright, do you think the cheese will still smell when we get it back now?
Yes.
Yes, okay.
It's gonna be stanky.
Sorry. And even worse, okay. Thanks for helping us out.
Yes, sir.
I'm glad you guys had fun.
That was fun.
See you later.
Then back here at the museum, we were designing the balloon itself. We were designing the equipment that made sure that we could recover it. We were working with scientists and engineers all over the world to make sure that we had that material ready to go, give us the highest chance of retrieving that. We had to learn all about stratospheric weather, where those balloons would travel and how to predict that, to help us guide our flight path, help us launch the balloon in the right spot so it landed in the right spot. Balloons don't have rockets or propellers that let us steer them back and forth and pick exactly where they're going to go. And then we had to make sure that both our equipment that we needed and the kids' experiments were small and light enough that they fit inside the small box we had to make sure that the balloon could take them up to the edge of space and back down again. Everything is taped up inside the box. The whole ballooning process is a pretty violent one. A lot of energy in these balloons, both when they take off, when the balloon bursts, when it gets up to its highest altitude and the balloon pops, the whole thing will fall at over 100 miles an hour for a few minutes before there's enough air to open the parachute. It's very tight. Basically, if you wouldn't be okay throwing your whole package down a flight of stairs, you shouldn't fly it. Okay, so the batteries are taped in, the camera is taped in, the Raspberry Pi camera, the flight computer is taped in, all 3 antennas are attached and plugged in. We have our 2 experiments basically ready to go. Tomorrow we'll send it to space. This is made out of latex. It's a natural rubber. It's not a synthetic or anything like that. And this balloon will be about 25 feet around when it pops. It's enormous when it pops up in the near space. So it's just like a giant party balloon. It fills through a nozzle at the bottom, and the gas goes into the rest of it. So what we're gonna do is we're going to fill it, tie it off, and attach it to our train. Once that's done, we're gonna hold it, and we're gonna connect our cameras, turn on our radio repeater, and then when 540 hits, it's gonna go up in the air. There's no wind right now, which is great, because there's power lines and basketball hoops and stuff around. So any wind would make this spot a really terrible spot to launch a balloon. Because there's not very much wind, it should go straight up, we hope. Okay. I wasn't either. Starting to get where I can feel that the water doesn't want to keep it on the ground anymore. Okay, I've got it. So you want to make sure you talk to the other person so that you're not left with a situation where the balloon is taking off because you thought the other person had it. So we are all ready to go. Launched the balloon. It's about 2,000 meters, which is roughly, 6,500, 7,000 feet. And somebody in Houston has picked up what's called our APRS signal, which is an amateur radio location beacon. So someone in the middle of Houston has heard the signal chirping out of our balloon, which is awesome. It means that our APRS beacon is on the map and is working. That's a harder thing to test for us since we only have one radio in the car. So it's really great that we know that's working. And actually, as we've talked, the balloon has gained about another 1,000 feet of altitude. So right now we've got, even at our relatively low altitude, we've got basically everybody from Houston to Victoria can hear the radio at this point. We're in the space equivalent zone now, the balloon is, but not quite as space-like as it'll be about half an hour. I'm not really sure where it's going to land. I hope not in the river.
Yeah, I've been watching that with apprehension as well.
So early on in this project, we got connected with the Victoria Amateur Radio Club. These are a group of amateur radio enthusiasts who've been really helpful. One of the most helpful was a man named Harvey Babb. Harvey's got a long history in machining and engineering. In fact, he helped build the Aquarius underwater habitat that we talk about here in this exhibit. He helped us a lot with both balloon launches. He loaned us radio equipment that was invaluable for receiving the very weak, quiet signals from the balloon. And he helped track the balloon from his house here in Victoria. And that's really important because when you're driving along, it's very hard and not safe to spend a lot of time looking at screens and looking at radios. So it was nice to have somebody in a base station looking at the data coming in looking at maps, guiding us, giving us calls and saying, okay, the balloon's taken a turn to the west, the prediction has changed, in times where we couldn't necessarily pull over and look at the updated information that was coming into the laptops in the chase vehicle. Harvey got it a second ago. WB5MCT is his call. 36 seconds ago, we both got it. A couple other people have picked it up on the APRS, on the more sort of common frequency. This is a kind of special use frequency. It's not a common protocol. It's pretty much only used for balloons, and so not a lot of people are listening to it. In fact, only 2 appear to be listening to it.
Yeah, I'm not really sure what your best approach is.
It's like right on the other side of the road. There it is, see it? See it coming down? Orange? I've got visual, I'm on the other side of the road, but that's really cool. You can see it coming down. So we do have permission to do this. I was just let the camera know. We called, we got permission from the man who can give us permission to go on the land. We're not trespassing. Trespassing is a thing that is both a crime and wrong. Okay, so we're trudging through the brush right now. There's probably ankle to knee-high grass, lots of bugs, and we're headed towards a tree line. We're headed towards a tree line, and I'm hoping it clears out right after that. From Google Maps, it looks like it may.
Okay, copy your own foot. Yeah, it's tough copy either way on you.
Right here? Yeah. Boy. Oh, I see it. I'm on the right side of it. Okay, we found it. As you can tell by my sweat and my redness here, it is hot out here. It's hot and humid, and the balloon landed in a thorny tree, but with some climbing and some long sticks, we got it all the way down. About 8 hours after we left, but we've got the balloon. It's back from near space. Now the job is to go back in and look at what the balloon saw.
We here at the Museum of the Coastal Bend were really excited and proud to do this project and get so many people interested in spaceflight, from all the people who were interested in the first launch to the people we've gone out and talked to, the students both in Texas and New Mexico that have taken part by launching experiments to the edge of space. This has really opened up space research and space science to a lot of people who might not have realized that it was an accessible pursuit, might not have realized that this was either a future career path or something that they could do as a hobby. This is very accessible. It takes a lot of work and a lot of thought, but really not a lot of money. This is a goal that a lot of people can achieve, and we were happy to make that point and to help a lot of people realize that.